Today I'm going to talk about LeetCode question number 138, copy list with random pointer. A linked list of length n is given such that each node contains an additional random pointer, which could point to any node in the list or null. So we don't just have next pointers here, we also have random pointers that could point to any node in the list or none. Construct a deep copy of the list. A deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of its corresponding original node. Both next and random pointer of the new node should point to the new nodes in the copy list, such that the pointers in the original list and copy list represent the same list state. None of the pointers in the new list should point to nodes in the original list. For example, if there are two nodes x and y in the original list where x.random points to y, then for the corresponding two nodes x lowercase x and y in the copied list, x.random points to the copied y, return the head of the copied list. Okay. So the linked list is represented in the input-output of list and nodes. Each node is represented as a pair of val random index. Okay, that's just talking about the input format. Okay, so basically, yeah, we have to create a deep copy of this list, an entirely new linked list, where it's exactly the same as the original list, and there's none of the pointers refer to the original list here. So if we have like 1, 2, and 2's random pointer points to itself, 1's random pointer points to 2. That's null. Then we basically need to create a new list. Maybe I'll drop it as a box here to differentiate. Okay, and none of these pointers can refer to the original list. Okay, so how do we do that? How do we go about this? And yeah, so one thing we could do is, we could traverse. One way to think of it is to traverse through the list, and as we traverse, create new nodes. So as we traverse through this list, I'll just copy it up here. Okay, and this has various random pointers. So for example, I'm just going to omit the random pointers for now, just because it'll make the diagram very messy. So yeah, as we're traversing the list, we can create new node objects. Okay, so we create a 7 here, and then as we create these new node objects, we see what it points in the next pointer and the random pointer. Okay, so we see this points to 13, so we create a 13, and this random points to null, so have that random point to null. Okay, and then I guess similarly for 13, problem is we already created 13 here. Okay, how do we prevent duplicate creations of nodes? So the question then becomes, how do we know for a node that we already created a duplicate node for it? So a good way is to use a dictionary. A dictionary does a key value store. It's O1 lookup, and in this dictionary, what we store is the original node and the copy of the node. Okay, so what we do is for each node, we refer the original to the copy. We create copies for the node here, and then store this mapping between the original and the copy. Deep copy, I might add. Oops. Okay, so we traverse through the list, go through that, and then we traverse through the list again, this time looking at the next and random pointers. Okay, so for example, for 7 here, we look at the next pointer, and it points to 13. So let me do 7, 13, 7, 13, okay? So what we do is look up this original 7 in the dictionary, okay, find its deep copy, and then point its deep copy's next value to the deep copy of 13 node, okay? So what we do is basically do this, okay? And similarly for the random node, so in this case the random node points to null, so that's fine. But what if the random node doesn't point to null? So for example for 13 here, its random node points to 7. So we're at 13, but you see we have a value, a deep copy value for in the dictionary, and its random pointer points to 7 in the original list. So what we do is look up 7, original 7 in the dictionary, and make its copy's random pointer point to the deep copy of 7. Okay? And that's basically how we're going to go about this. We're going to use a dictionary here. And this is going to be obviously O of n time. Okay? Because we're traversing through n nodes in the length list. Okay, now to code this up, so I want to take care of an edge case first. So if head is null, head is none, then simply return none. Okay. Otherwise, we want to create a deep copy of the whole list. So first, what we're going to do is traverse through the list. So just going to make a copy of the head pointer so we don't lose the reference of the head to the very first pointer to the very first value in the list. So, okay, and also have my dictionary here, okay, and this is gonna map the deep copy to the original copy to the deep copy. So use that. So while h does not equal none, what we're going to do is create a deep copy. Goes node at h dot val, and then map this h is equal to, okay, and then increment each pointer. Cool. Okay, now that we have those mappings there of the original copy to the deep copy, all this. Okay, what we're going to do is traverse the list again, this time carefully looking at the next and random pointers. So I'm going to just reset h here. H is not equal, or not iterate through h actually, I want to iterate through, yeah, we can iterate through h, okay. Well, h is not equal to none. So basically, what I want to do is deep copy equals deep h, so that's my deep copy there. And what I want to do is have next copy and random copy, and then they're going to be none initially. Okay. So if h dot next does not equal none, then next copy is basically going to be the deep copy of h's next. So d h dot next, okay, and if h dot random is not none, random copy is going to be d random. Okay, so we have our deep copy, we have our next copy, deep copy, the random copy, deep copy. Now all that's left is to map them together. So deep copy dot next equal to next copy, and deep copy dot random equal to random copy. Okay, and yeah, that's basically it. If the deep copy or random copy happen to be none, then these if conditions won't execute, won't enter, but then we won't enter the if conditions, and these will continue being none. Okay. Finally, what we want to do is return the deep copy of the head. So return the head. Okay. And yeah, so let me try compiling it. Oh, you know what? I forgot to increment the h point h plus h dot next. Okay, this is going to time out. Yeah, that's expected. Yeah, so I added this, so we incremented h, so it eventually does reach none, the end of the list. Okay, great. Let me try the rest of the test cases here. Okay, now I'll try submitting. Okay, great. Thanks for watching.